All right, ladies and gentlemen, good morning, good afternoon, whenever you get the opportunity to see this video. Remember, I will not be there for a bit, but you are still responsible for learning, so there's no excuses. If you have any questions about anything in the lessons, then you need to feel free to email me or text me, and I'll be more than happy to give you the information that you need. My Google Voice number is going to be reposted on Google Classroom, and excuse me, and of course I'll repost my email for you guys as well. So you're responsible for your learning, and you're responsible to make sure you get the information. You're responsible to make sure if there's any questions that you get them asked. You are going to be equipped with guided notes. You have some other activities that need to be done. Remember what we said. Okay, you are going to be responsible in the time that I'm gone, and there should not be any behavior issues. Also, the rules still apply. So on the board when I left, I still put the gum, phones, headphones there. Bathroom rule still applies. We have bathroom passes for the week. Okay. Only one exception to that, and they know who they are. So there should not be any problems if I see more than 2 passes with your name on them this week. You're going to have some issues with me when I get back. I don't foresee that there's going to be any big problems with you guys. You're a great group of kids. I'm happy to be teaching you. So that's that. So we're going to get started today with oceans. Okay. Now, you have your warm-up sheet. If you do not have your warm-up answered, I got your sheet right in front of me. You have 4 warm-up questions. If you have not answered those warm-up questions yet, we're going to pause the video, ask the video be paused right now, give you a chance to answer those warm-up questions before we go on with answers. So again, if the warm-up's not answered right now, let's pause the video before we go on. All right, so hopefully that gave you enough time to pause. Now we can go over these warm-up questions. It says, water that does not infiltrate the soil most likely do what? Runoff, not flood, okay? We shouldn't have put flood first. First we do runoff, okay? Excuse me one second, guys. We got to plug up. All right, question number 2 says, what is the term to describe the space between pores in the soil? Hopefully you put porosity, okay? Porosity. That talks about the pore space in between the soil that you have. All right, number 3. What region is the Outer Banks located? Remember, North Carolina has 3 regions. We have the mountains, the Piedmont, and the coastal region. Okay, so for your mountains, you got your area of like Asheville. Piedmont is where you live in, and the coastal regions are like places like Wilmington. So North Carolina, Outer Banks is on the coast of North Carolina. All right, number 4 says, which river basin is located in Gaston County? Okay. Our main river basin is the Catawba River. Now remember, the Catawba River also not only flows in North Carolina, it flows to South Carolina as well. Okay. So we had that question on river basins about how could South Carolina sue North Carolina for water pollution? Well, because anytime we have a water basin going from one state to another, states are responsible for that. Okay, both states are responsible. All right, let's take a few seconds to pause the video now and let you get these notes copied. Okay, hopefully you had some time to do that. Excuse me. All right, we're looking at the movement of water, and the ocean water is constantly moving, and there's 2 reasons ocean water moves. One of them is wind. Wind is the uneven heating of the earth. Okay, so wind is always happening, even though we don't feel it. Okay, and the second one is the variation in density. So there are 2 reasons that density varies. 2 reasons density varies. One is temperature-wise. Now I'm telling you this is a test question, so pay attention. Okay, One is temperature. Yesterday, think about your lab. Okay? Are you thinking about it? Are you? All right, so in your lab, what did you notice about the warm water and the cold water? So the warm water rose to the top and the cold water sank toward the bottom. So yeah, some people got some mixtures of purple in between, but I'm sure if we would have let it set longer, then we would have saw that the warm water would have stayed at the top and the blue water, which was the cold water, would have stayed toward the bottom. So temperature is one variation in density. The second cause of variation in density is salinity. Okay? And salinity varies, and salinity in the ocean, now remember that's what separates ocean water from fresh water, is the salt content. Okay? And that's called salinity. So ocean water has salinity. Okay? 97% of the our water is salt water. Okay? So the salinity varies. So the more salt that you'll have in a substance is going to be more dense than the less salt you have in the substance. Okay? So variations in variations in density include temperature and salinity. Again, test questions. Remember that, temperature and salinity. All right, so take a few seconds to pause, get your info. Okay, hopefully you had some time to copy that. And we're looking at specific heat. Water is a pretty awesome substance for a lot of reasons. One, water is the only substance on Earth that you will find in all three states of matter. That is solid, liquid, and gas. Okay? Water has a specific heat, which means a specific heat is how much does it take to raise the temperature of a substance. Okay? So it takes a lot of energy to heat up water and to also cool water. All right, take a few moments, get this slide copied. All right, so hopefully you had some time to go ahead and copy that one as well. Now we're looking at these density currents. So we said there's a variation in density. And because of these variation in density, these ocean currents are moving. So wind and density. So the density currents are ocean currents that move due to difference in density. What are those two differences that we talked about? Temperature and salinity. Write that down. Okay, it is not currently what I can see on your notes, but write those down. Density and salinity. All right, I see also that you have a video here that will help you answer the question of what is upwelling and why is it important. You're actually going to have to go back to that video at the end of the video lecture to help you with what is upwelling and that process. All right, pause the video, get your notes copied. All right, so we're looking at the ocean currents and we're looking at the Coriolis effect. So because the Earth rotates on its axis, circulating air, that's the air that's circulating, is deflected toward the right in the northern hemisphere and to the left in the southern hemisphere. Okay? This deflection is called the Coriolis effect. So if the wind was, we have to think about this is wind. What would happen if the wind did not blow? If the wind did not blow, we would have wind going from north pole to south pole to north pole. So it only flow in that up and down direction. But because of the Earth's rotation, we know that the wind is going to be blowing in more of a east to west direction. So we're looking at patterns. The Earth rotates on the axis from west to east. This rotation causes both the wind and ocean currents to move from east to west. Thus, the wind movement and ocean currents in the northern hemisphere gives clockwise, how the regular clock would go, and then the counterclockwise, it's going to be in the southern hemisphere. And we'll talk more about the Coriolis effect when I return. All right, pause video. All right, so looking at gyres. Gyres are large circular current systems that flow from north to south and are caused by the Coriolis effect. So we just talked about the Coriolis effect and its causes and what it is. Now looking at gyres, one of the offsprings or products of the Coriolis effect. And with the gyres, I want you to think about similar to Earth in a way that there's a central point and the water surrounds that central point. So when we rotate on our axis, Earth rotates on its axis. Think about these gyres are also rotating at a central point. Also think about a whirlpool or the bathtub, for example. When you let the water out, sometimes you can see how the water goes as it gets closer to the end, that circular pattern that it does. So that's what the gyres, okay? They're just massive movements of ocean currents that continue in a circular pattern. There are 5 of these. If you note, at the equator, they're near the equator, they're not at the equator, so they're not really doing any crossing over of the equator. There's no Coriolis effect at the equator. So if there's no Coriolis effect at the equator and the gyres are caused by the Coriolis effect, the gyres are not going to be there, going to be happening at the equator. So there's no crossover for the equator. I do want to talk a little bit more about gyres. One of the reasons that they're so important to marine life is upwelling, and we haven't gotten to upwelling yet. I know you're going to be watching that video, but upwelling takes water from the bottom of the ocean, not the bottom, but further down in the ocean, and pushes it up forward, okay, closer to the surface where more of the marine life and organisms can get to the nutrients that are provided. So think about it, all the good stuff floating at the bottom, okay, is sinking. Upwelling allows for it to come up. That's actually a test question too. So upwelling is when the ocean water is pushed up further to where more of the organisms live, then they feed off those nutrients. So that's important to marine life, and gyres are a process of that upwelling, or help with the upwelling, assist with the upwelling. I don't know what term I want to use there for that. One of the issues that occurs with gyres is there's a pollution factor, and I believe the video that was chosen is going to speak about that pollution factor. What's happening is there's a lot of plastics in the ocean, and they seem to be caught up in this circular pattern of the gyres. So that's one negative impact that humans have on these, is because of the pollution that's there. So I'm going to read you a little something real quick. It says, improperly disposed of plastics that find their way into the oceans tend to accumulate into one of these 5 gyres. The swirling action of the ocean gyres cause any debris caught in it to gradually make its way to the center where there is little water movement. It's concerning because its effect on sea life like plankton are uncertain but assumed to be detrimental. So when you have basically this area of trash, almost like a little trash island caught in these gyres, that's how is the plankton going to get the food that they need? Okay, so those smaller marine organisms, how are they going to get what they need for survival? And keep in mind that upwelling and gyres is on your test. Okay, pause the video. All right, so hopefully you had time to do that. I want to look at your surface currents. With the surface currents, they are currents that affect the uppermost portions of the surface. So you're looking at, you have an entire ocean, and that upper part of that ocean is going to be your surface currents. So the rest of them are still ocean currents happening, but that upper part is what you're looking at. Compare it to the lithosphere. How we have those parts of the earth, we have the core, the mantle, and the crust. And the lithosphere is the entire crust and part of that upper mantle. we still think of that as the surface currents are a layer of the Earth, just the upper part. So surface currents flow towards the equator generally bring colder water. Surface currents that flow away from the equator generally bring warmer water. Because think about the equator, okay, it's the center, and that center of our Earth, if it was divided, okay, that imaginary line, we are known that the temperature at the equator, is it colder or warmer? Normally it's warmer, okay? So anything that flows from that warmer area or from the warmth is going to be warmer. Now think about your poles, your North Pole and your South Pole. Those poles are known for being what kind of temperature? Cooler or warmer? They're known for being cooler. So anything that flows from the pole is going to be colder water. And that's actually another question from your exam, okay? Think about that. Or another topic question from your exam. The water that flows from the, and it's right there, perfect example on the bottom of your screen, or on the bottom of this screen, I see your warm currents. Notice those arrows are what is flowing from the equator. And those cool currents are what are flowing from the poles, okay, toward the center. It'll also work like a convection current in a way, okay, separating your warm currents from your cold currents. I'm looking at the top where it says warm currents right now. So that heat is going to rise. Okay, think about your pot. It's going to rise. Okay, then it's going to get colder and sink. And it works the opposite way in the southern hemisphere. So this map is included to look at, it appears, not only your gyres, but to also look at the patterns better of your warm water and cold water flowing through. That previous slide had a video. You'll have to go back to that one. And pause. Okay, so as we look at the ocean currents, the information that we need to look at is the climate impact that these areas have. And the coastal areas have a high amount of water vapor in the air. So remember we talked about that water is the only substance that on Earth occurring naturally that is in all three states of matter. So we're looking at the fact that the summers in the coastal areas will be cooler and the winters will be warmer. All right, now let's go to the next one and I'll explain why that is going to be. All right, pausing real quick, copy this last slide down. So we looked at the previous slide about coastal areas. Now we need to look at cities that are further from the coast, because cities that are farther from the coast have summers that will be hotter and winters that will be colder. So we have to look at why is that, and this is a test question, just to FYI you a little bit. Okay. This is another one. So it all goes down to specific heat, or all comes down to the specific heat index. And we talked about a few slides ago about how much energy it takes to heat water and how much energy it's going to take to cool it down. So because of high specific heat, it takes longer for water to get heated up or to get cooled down. During summer days, the land near the ocean gets heated up quickly, but the ocean water remains cool, and thus the cool breeze blowing from the ocean reduces the heat close to the land. So think about when you're on the beach, if you've ever been to the beach, you get that nice breeze that flows, okay? It's cooler. So that's why when you look at your temperatures, next time you look at the forecast, look at the temperature in the mountains, look at the temperature in the Piedmont, look at the temperature at the coast, okay? Due to elevation, your mountain areas are going to have colder temperatures. And your Piedmont region Okay, I'm sorry. That was for the winter. Let me discuss for the summer real quick. Let me back up first. For your summer months, okay? Due to the elevation, your mountain region of North Carolina is going to have varying temperatures, mostly due to the elevation. But when you look at the Piedmont region and the coastal region, your coastal region is going to be areas that is going to be cooler than your Piedmont region is going to be. And the reason for that is because of that sea breeze that's blowing. If you've ever been to the beach on a hot day, that wind blowing feels so good because that wind is blowing from the ocean, which is cooler water than it is going to be on land. I hope I explained that right. If not, if I hope I explained that to where it's understandable for you. If I did not, please let me know. We can always talk about that more. All right, so going back to that, so now that we know why it's cooler in the summer, the reverse happens in the winter. The land gets cooled quickly, but the ocean water remains warm, and thus the land gets warm breeze from the ocean. But the land further inside, and that's what we call inland when it's further inside, does not have this advantage. Okay? So this is the difference for the climate shifts that we have. All right, guys. Well, what you need to do now is after the video is over, go back to the Google slide presentation that is in Google Docs with this presentation here, and just click on the links. The first link will not work for you because we no longer have Discovery Ed anymore, but all the YouTube ones should work for you. Okay. All right, behave yourselves, do your work. I'll see you soon.